Hello students, welcome to section 3.2, graphing linear inequalities in two variables. So learning targets. I can graph the equation of a line. I can determine if the line should be dashed or solid. I can determine which area of the graph is to be shaded. And finally, I can determine if a point is a solution of an inequality. So linear inequality, a linear function y equals mx plus b that contains inequality symbol. In other words, instead of equal sign, you see greater than, less than, greater or equal, or less than or equal. Okay, so very similar to y equals mx plus b. The only difference is instead of equal symbol, you see inequality. And the solution, an ordered pair x comma y, that makes the inequality true. So the word that goes over here is inequality. And note, for a linear inequality, there are infinite number of solutions. Okay. So let's talk about the steps. We have 4 steps for you, so you can do this. You can follow our steps. So step number 1 is write the inequality in slope-intercept form, which means y equals mx plus b. Okay. Graph the line using a dashed line or solid line, and we'll talk about this in a few minutes. Test 0, 0. Okay, test the point. If the line goes through these 0, 0, you must pick a different point, and you'll see it later. And then step 4 is shade on appropriate side of the line, either shaded below or above. So let's review a little bit. Dashed line, or sometimes I call this dotted line, okay, we use it when we have, so dashed line would be like that. We use it if it's greater than or less than. Do you remember open circle for less than or greater than? And solid line we use for greater than or less than. And if you recall from our previous section, we used solid circle when we were graphing inequalities on a number line. Okay? So I think the best thing to do is actually go over a few examples, otherwise it's very hard to explain all the steps. So let's take a look at example number 1. Okay, we have 3 examples for you, and I will explain them all in depth. So example number 1, graph the inequality. Okay, so step 1 is to rewrite this inequality in y equals mx plus b form. So first thing you should do, you should add x to both sides or put negative x on the other side. So if you add x to both sides, you will get y is less than or equal to x plus 5. Okay, again, all I did is I added x to both sides. Now think about this equation as y equals mx plus b. So if you recall from our review, a summer review, in this case m is equal to 1 over 1, and your y-intercept, the initial value, is equal to 5. So how do we graph this? Okay, assuming the scale is 1 by 1, okay, we start at 5, so 1, 2, 3, 4, 5. Just so you know, it's very hard for me to write this using my pen. 1, 2, 3, 4, 5, that is correct. And the slope is 1 over 1, which means 1 up, 1 over, 1 up, 1 over, okay? So like here, 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 and here. So basically it's like a diagonal line, okay? Now the next step is I will graph it. But the question is, do we have a dotted line or dashed line or solid line? Okay? So since we have less than or equal, so step 2, you should have a solid line. And again, that line should go through all the points. Again, it's very hard for me to draw a line on my iPad. Okay, so this is supposed to be solid line. Okay, now the question is, do we shade it above the line or below the line? Okay, so let's test 0.00. Okay, now x comma y. So let's substitute 0 for x, let's substitute 0 for y, and let's see if we get a true statement. So you will get -0 plus 0 less than or equal to 5. Okay, I'm going to put question mark above it because I'm testing it. 0 is less than or equal to 5. Now this is a true statement. Okay, this is true. That means that 0, 0, which is the origin, should be shaded. So that means that I am shading anything below the line. Okay, so the solution set is all the numbers, all the order pairs that I shaded. Okay, so on your quiz or on your homework, you are expected to shade it. Okay, so this was example number 1. Now example number 2. Example number 2 is actually easier, but in some way it's harder because we don't have y equals mx plus b. We technically have x is less than 2. Okay, if you recall from our summer review, okay, how do you graph x is equal to 2? X equals 2 is technically a vertical line, it's not a function. Y equals 2 would be horizontal line, but x equals 2 is a vertical line. So all you do is you draw a line that goes through 2 comma 0. Now the question is, should that be solid line or dotted line? Okay, should be dashed line because it's less. So this symbol indicates I will have dashed line. So I'm just drawing dashed line like this. Okay, so this will be x is equal to 2. But I am interested in x is less than 2. Okay, so x less than 2, so let's test 0, 0. Again, x is 0, y is 0. So 0, let's test 0 less than 2. Is that true? Yes, it is. This is a true statement, which means that origin should be shaded. Now, if this wasn't a true statement, I would shade the opposite. I wouldn't shade the origin. Since this statement is true, 0 is less than 2, I will shade this side. Okay, so the solution set is all the order pairs, all numbers, all the order pairs on the left side. So now you can probably figure out question number 3. Since question number 2 was x equals, now we have in number 3 y equals, or y greater than 3. So think about y is equal to 3. How do you graph y equals 3? It's a horizontal line with slope 0 and y-intercept 3. So in other words, it would be a line that goes through this point, 0, 3. Okay, but now because I have greater than or equal symbol, I will have a solid line. So I'm going to draw a solid horizontal line that goes through 0, 3. Okay, and now the question is, are we going to shade it above or are we going to shade it below? Some students just predicted because it's greater than, which means I'm going to shade it above, but let's test 0, 0. So if you test 0, 0, x is 0, y is 0. Okay? So we know that y is greater or equal to 3. Okay, so y greater or equal to 3. So I get 0 greater or equal to 3. Okay, so is this true? This is not true. This is false. So therefore, this means that origin shouldn't be included, shouldn't be shaded, okay? Because if this is false, I'm not including the origin. So I'm not shading everything below the line. So that means I have to shade it above it. Therefore, my solution set, all ordered pairs that are above the line. Okay, this should be kind of shaded. If you have color pencils, that will be easier. But the solution set is all the ordered pairs above the line. Okay, actually also on the line. So the second part of the lesson, okay, we will talk about the objective or the learning target is I can determine if a point is a solution of an inequality. Okay, so we have one example for you that you can read on your own. You can follow the steps, and I will go straight to the example we prepared for you. Okay, so what I will do, I will divide this paper into like maybe 3 parts, because there are basically 3 questions and they are independent. Some students think that the questions are connected. That is not true. So practice. Determine if any of the following points are solutions to the inequality. So let's start with question A. Question A, x is equal to 3 and y is equal to -7. In other words, x is 3, y is equal to -7. So I will substitute 3, so y is, so basically if I do y is greater or equal to 3x plus 5. Now I will substitute. For y, I will put -7. Greater than or equal to 3 times 3 minus 7. Okay, now let's continue. -7 greater or equal to 9 minus 7. So I get -7 is greater or equal to 2. Now, think for a second. Is this true? Is -7 greater or equal to 2? The answer is no. Okay, so your answer should be it's not a solution. Okay, so the final answer should be not a solution. In other words, point 3 -7 is not a solution to the given inequality. What I would like you to do is actually pause the video and try example B, so that way you can see if you understand it. So pause this video for about 2 minutes, try number 2, and then watch the video after you finish. So question number 2, or question B, x is equal to 2, y is equal to 11. Okay, so again, I'm going to rewrite the equation. Actually, it's inequality, not equation. Y greater or equal to 3x plus 5. Let's substitute. 11 is greater or equal to 3 times 2 plus 5. So you get 11 is greater or equal to 6 plus 5. Okay, and this is a very interesting problem. You get 11 is greater or equal to 11. Okay, think about this. Is this statement true? Is 11 greater or equal to 11? Yes, it is. Okay, because 11 is equal to 11. So the answer is yes, it is a solution. So the answer would be yes. Now, if in this problem we had y is greater than, instead of, if it was only greater than, like this, that wouldn't be true, because 11 is not greater than 11. Okay, so just pay attention. All right, last question, question C. So x is 8, y is 9. I always encourage my students to write it above the order pair. That way you know you don't confuse it. Y greater or equal to 3x plus 5. So I will get 9 is greater or equal to 3 times 8 plus 5. So 9 is greater than or equal to 24 plus 5. 9 is greater or equal to 29. Think about it. Is 9 greater than 29? The answer is no. So this means that the order pair 8, 9 is not a solution to the given inequality. Okay? I hope this video helps you and you understand this lesson. Again, in class, please ask questions. Thank you very much for watching the video. Have a good day.